won't mix up the words, okay? So if weather was probable, okay, then what it would mean is like, let's say I had a dice, right? 6 sides on the dice. Let's say each side represented a type of weather. One side had a sun, sunny. One side had raindrops. One side had snow. One side had wind, cloudy, and how about hail, right? It's not like Mother Nature wakes up every morning and rolls the dice, and that's what the weather is, right? Sometimes it feels that way in Utah. Sometimes it feels that way in Utah in a single day, right? It'll be 80 and then it'll be like snowing an hour later, right? But it's not like each day it's just random and we just roll a dice and that's what the weather is, right? No, we can predict the likelihood of whether or not it's going to rain based on like clouds, right? We're taking an educated guess. So that's basically the main difference between predictable percentages and probable percentages is, am I taking an educated guess or is it just kind of luck of the draw? Okay, does that make sense? We're doing okay? Can you guys think of another type of percentage that's predictable, not probable? Everything we've done so far this unit has been probable, right? We rolled dice. We did the experiment where we picked out the red, white, or blue chips from the bag, right? What's another example of a predictable percentage, not a probable percentage? Can you think of anything?
Volcano eruption.
That's a great one, right? Volcano eruption, okay? Anyone else? Anyone? Have you guys ever heard of the big one that they talk about in Utah? The big giant earthquake that they know will happen eventually, right? Yeah. So apparently, because of Utah is on fault lines, right? They know based on, well, they can predict based on how long it's been since a really big earthquake that there's a really big earthquake eventually that has to happen in Utah because of where the tectonic plates are. It has to happen, and it's going to be catastrophic, right? Could be next year, could be in 50 years, could be in 200 years. They don't know, but they know eventually it has to happen, right? Predictable, okay? Come on, you guys wake up. Tell me another one. What's a predictable percentage, not a probable percentage? Remember, we're looking for educated guesses, not luck of the draw. Predictable percentage, not a probable percentage. Population growth, very predictable, right? That's how they know. Like, okay, so I started teaching here at Westlake like 6 years ago. But even before that, I taught at Lone Peak for 8 years, okay? So I'm old, I get it, right? I look great. You don't realize how old I am, okay? But when I first started driving to Lone Peak, have you guys ever been there? It's like walking Cedar Hills, right? I don't know if you've been there now, but like Traverse Outlet Mall, that wasn't there. In fact, once you got off I-15, there was nothing. No housing, no malls, right? Canyon, what's the name of that? That new Skyridge. Skyridge wasn't there. None of the houses that feed into Skyridge was there, right? So in the last decade, like, think of that area has boomed, right? Well, they can predict that, so they start like building things before. That's a great example. What is another example of a predictable percentage? Just so I make sure you guys understand the difference. Predictable, not probable. Anybody else? Come on, I want one more. Predictable, not probable. Predictable, not probable. Come on, guys, wake up. It's a Wednesday. Look at your notes. Maybe there's some examples on your notes you could use if you were, right? Anyone? There's new notes for today.
What about your kid drawing on the tablet tomorrow?
My kids are what?
What about the predictability of your kid drawing on the tablet tomorrow?
Oh, that's 100%, right? Unless it dies or I forget it at work, but that's very predictable, right?
Wait, your kid or your tablet?
Honestly, these days it could be either one. Okay? This was the class that I forgot to take Lily to daycare, right?
Yeah.
Yeah, so that's the whole thing, right? So it could be either one, Tice, right? But that's a good idea, okay? How are we doing? Okay? I don't mean any shade by this, so don't think this is shady, okay? But let's say in our high school football group, no shade, right? In our high school football group, let's say there's 10 high schools, right? If our chances of winning state football championship were probable, then that would mean we'd have a 1 out of 10 chance because we're one team out of the 10 total teams, right? That's what it would be if our percentages were probable. But is that reality? No shade.
Yeah, it's reality.
Yeah. It is reality?
Yeah.
We have a 1 out of 10 chance?
Oh, we're bad.
Yeah,
What do you
even
mean?
chance-
That's the whole point of what I'm saying. If our football team, our chances of winning were probable, then it would be 1 out of 10, because there's 10 schools, one of us. But it's probably more predictable, right? Because not each team has the same chances of winning. That's basically the difference of what we're going to be talking about today, predictability and probability, okay? Good? Does that make sense? Does that help? Okay. So another predictable example of percentages is coupons. Okay. So today, have any of you guys, either yourself or your parent, been like you're at line at like Kohl's or the grocery store or Michael's, and you got a line of people behind you, and you're trying to figure out what coupon is going to help you most, but it's like kind of stressful because there's a ton of people there, right? Okay, I do that all the time, especially at Michael's. Okay, because there's always, I can get one on my phone or in mail or whatever, right? So today we're going to talk about, does it matter what order you give the coupon to the cashier, and how can you decide, right? Quickly, all right? So why is this situation predictable percentages, not probable percentages? Why are coupons predictable percentages, not probable percentages? Anyone have any thoughts?
Because if you have them, you'll probably use them.
Okay, if I have them, I'm probably going to use them. Is it like random how much so remember the difference is it luck of the draw or is it an educated guess? If Miss Summers walks into, okay, let's say I went to Harry Potter World, okay? Is it predictable how much money I'm going to spend? No? Yeah, it's pretty predictable. I'm gonna spend more than $100 probably, right? Because I love Harry Potter. Yeah, Jacob, were you gonna add something?
Yeah, I was going to say the coupon's predictable because it tells you exactly how much it's going to take off the price.
Exactly, it's predictable because it tells you how much you're gonna get off. It's not random, and I can say if I go into a certain type of store based on what I like in that store, I can guess how much money I might spend. Does that help? That's perfect. Okay, good. So let's say I was going to spend $150, okay, at Kohl's. Now these coupons, these are real coupons actually. Miss Stone, the other secondary 2 teacher, she just took pictures of them. She cut the barcode off so nobody would try and use them.
She thinks we'll try to steal this.
I literally had students in my last class be like, well, where's the rest of the barcode? So, yeah, not our first rodeo, okay?
I didn't know there were barcodes.
Yeah. So here, I'm spending $150, okay? We're going to call this one coupon number 1 and this one coupon number 2. So first of all, before you even do any math, I want you to take an educated guess. I want you to say, just write it somewhere up here, yes or no. Do you think it matters what order I give the coupons? Okay. And if you think yes, I want to know which coupon you think I should give first. All right? So take 20 seconds and make a guess. Do you think it matters what order I give the coupons? And if you think it does matter, then take a guess which coupon you should give first. Okay? All right. Can I have somebody raise their hand who thought it matters what order you give the coupons? Jacob, you think it matters? Which one do you think I should give first?
The $20 off one, because then you get 25% off of the remaining total.
Okay. It's a good guess, yeah? Trina, was your hand up too? You're gonna say the same thing? Okay, Zach?
So, well, I would do the 25% off because you're taking a percent off of the higher number.
Okay.
And $20 would just start $20.
Okay.
Yeah, what was that?
You're with Zach? Okay, let's find out. So, do you guys remember how to take 25% off something? Okay, so take your 25%, oops, and turn it back into a decimal. So 0.25, okay? Then times that by your 150. What does that give you?
Take off $37.50.
Okay. Now that's how much I have off, right? So how do I figure out what I'm spending if that's how much my coupon is taking off? Good, Tatum. Subtract it from 150. So I'm at 112.50. Now let's apply coupon number 2. So if I apply coupon number 1 first, I'm going to take my 150 down to 92.50. Okay? Now let's try it again, but we're going to apply coupon number 2 first. So if I apply coupon number 2 first, I'm going to times my 0.25 times the 130. Am I going too fast? You guys doing okay? Okay. What do I get? Anyone?
32.5.
Okay. So then I'll take my 130 minus my 32.5 to find out how much I'm paying in the end. So it did matter, right? I mean, $5 is $5. Okay? Which coupon would be better to give first? The first one, okay? Is that always going to be the case? Okay, when would that change? When would it be better to give coupon number 1 or number 2 first?
When like the total's lower.
When the total's lower? Yeah. Okay, let's try another one here. I want you to try this situation again, but let's say I'm spending $110. Okay, so I want you to take a second and I want you to apply each coupon one at a time again, and then we'll talk about it. If it's predictable that which coupon is better, when, okay? So take a second. I'll walk around and make sure you guys are doing all right. But I want you to take a second and answer A and B again, but with this amount, and see if it's still better to do coupon number 1 first.